Hey, hello everyone. Welcome to today's stream of lead code discussion. We will be starting within a minute. So hello everyone. Let's start the discussion for biweekly contest 172. So let's move to the first problem. The very first problem says that we are given a integer array nums. In one operation, we can remove the first three elements of current array. If there are fewer than three elements remaining, all the remaining elements should be removed. Repeat this operation until the array is empty or contains no duplicate values. Okay.
Um, Mic test. Hello.
Hello. Hey, hello. It's a mic test. Okay, so let's start with the discussion. So the very first problem says that we are given an integer array, say nums. In one operation, we can remove the first three elements of the current array. If there are fewer than three elements, all the elements need to be removed. Now repeat this process until array is empty or contains no duplicate values. Return an integer denoting the number of operations required. Okay, so what does the problem statement say? For example, we have this array given to us. Now we need to do the given operation until and unless the array is empty or is free of duplicate values. Is there a duplicate value in this array? The 3 in the first index is also present on the third index. So it is a duplicate value. Alright. Duplicate value is our values that are present multiple times. Now we need to get rid of this. And how to get rid of that? Just do the operation. What does the operation say? Operation says to remove the first three elements unless and until uh, the duplicate value condition is satisfied. So in the first operation, the very first operation which we apply, we are remaining the first three elements from our array. We are removing this, so the array becomes 658. Now is there a duplicate element? No, it's not present. So this is our answer. What do we need to return? We need to return the number of operations that we have applied on our array. So how many operations we needed to apply? It is 1. Now in this example, the array is 2 2. All right. So is there a duplicate element? Yes, 2 is present 2 times. So apply the operation. What does the operation say? Remove the first three element, or if there are fewer than three elements, remove all the elements. So removing all the elements, our array is empty. An empty array is always a good array. That is, it is free of duplicates. And we need not apply any more operation. How many operation we needed to apply? One operation. So the answer is 1. Now in this array, is there a duplicate value? 1 is present 1 times, 2 is present 1 times, 3 is present 1 times, 4 is present 1 times, and 5 is present 1 times. So no duplicate value means no operation need to be applied. Alright, so the answer should be 0 and it is 0. So what do we need to do? Applying the operation, what do we do? Just iterate over the first three elements and remove them. So applying is easy and can be done in O of n. A single operation needs three computations to be applied. Okay, so it is approximately O of 1. And at max, how many operation can be applied? It is n by 3. After that, the array will be empty. So applying an operation is pretty much computable. It is pretty much O of n. All right. But what this O notation denote? It denote the number of operations or computations that the machine need to do. This plus, multiplied, minus, all these are one computation or one computation which the machine does. So applying operation is approximately doing n calculations. All right. Now coming to the second part. Second part is checking whether array is free of duplicates or not. The checking part, what do we need to do? We need to iterate over all the sets of elements present to us and check its count after every operation. So it would be O of n again. And if we do this after applying all the operations. Okay, after applying each operation, we are checking that if our array is free of duplicate values or not. It would be an into n, which is not computable in the scenario given to us. So we need to do some optimization here. So what optimization can we do? Okay. So we need to do some clever optimization to reduce our complexity. All right. Is it working? Yes, it is. Okay. So checking also takes O of n if we do it after each operation. So we need to do some clever optimization. What is our optimization? We can maintain the of count of duplicate elements. Okay. Initially, let's say our array had in this scenario. Okay. In this scenario, our array had one duplicate element, which is 2. All right. So we needed to apply one operation. And if we had a count of that value, that is how many duplicate elements are there, after applying one operation, we can just see that, okay, we have removed 2 and 2 was a duplicate element. So the count of duplicate elements has reduced by 1. And at the end, when our count goes to 0, that is our answer. So apply operation until count is greater than 0. All right. And at the point the count is 0, we just need to return the number of operations we have applied until now. So let's move to the implementation part of this code. Okay. So let's move to the implementation part. What do